Good morning. In this video, I'm going to discuss compressors. So first, we're going to discuss how to choose the type of compressor, and then uh, we'll try to calculate the horsepower of a compressor. So those two things are the things that we need to specify as a chemical engineer. So let me share the PowerPoint. So just like pumps, no, generally there are two types of compressor: the positive displacement and the continuous flow. So as you can see, for the continuous flow, these are the centrifugal type of compressors, ano? And for positive displacement, you have the rotary and the reciprocating. So for the rotary, you have the sliding vane, the liquid piston, the straight lobe, and the helical. So as you can see, this is very similar to our pumps, no? So the helical is similar to the helical screw type pump, liquid piston. Probably you have a piston, ano? And for the continuous flow, you have the centrifugal and the axial, which is quite similar to the pump, no? So generally, the compressor and the pump have the same principle. The only difference is that compressor are used for gases, while pumps are used for liquids. So, so in order to specify the type of compressor, generally we are just using this diagram from our handbook. Ano, you can find this on figure 10-62. So just browse the chapter 10 of the 8th edition. So basically you need the flow rate, no, in cubic foot per minute, no, in cubic foot per minute. And then on the y-axis, you have the pressure ratio. So hanggang 30 lang naman yung maximum possible. So generally, pag high flow rate, no, and low pressure ratio, you can use an axial flow compressor. So at relatively low flow rate, okay, around here, probably this is 1,000, probably at 500 cubic feet per minute. And then the pressure ratio is high. You can use a positive displacement. So you can use the uh, liquid piston compressor and other type of positive displacement compressor. Okay. So in calculating the horsepower, 100% efficient is a reversible adiabatic compressor. So in solving compressor horsepower, we're going to use these equations from Perry. Okay, you can find this on 10-44. Generally, these equations are introduced in chemical engineering thermodynamics. So, pero also this is also introduced in physical chemistry. Okay, the adiabatic equation. Basically, the idea is you need to solve for the temperature if you are given the pressure difference. So equation 10-72 is the most useful equation for compressor. Usually, the initial and final pressure uh, in a compressor is given, and also the initial temperature is given. So you should be able to calculate the final temperature. So from the final temperature, uh, generally in thermodynamics, we have this energy balance equation. It's based on the first law. So from energy balance equation, we have this equation delta H plus delta PE plus delta KE is equals to Q. Q is the frictional loss plus WS. WS is the head of the compressor. No? So generally, the potential energy is negligible. Just cancel it out. The kinetic energy is also negligible as compared to the delta H. No? Just cancel this out. And then also the frictional loss. We can neglect the frictional loss. So what happened is WS, this is the head of the compressor, is equals to delta H. And then when you assume that the gas is ideal, since WS is equals to delta H, so the general equation for in calculating the compressor's head is Cp delta T. So basically the idea is if you are given initial pressure and final pressure and initial temperature, just calculate the final temperature using this equation. And then proceed in calculating the head, no? So after you have the head, you can calculate the horsepower by using the power equation. The power equation is mass flow rate, no, times WS. So divided by the efficiency. Okay? So just try to convert this to horsepower. So that's the basic of horsepower calculation in compressor. So let's try to apply this in a sample problem. We have here the power equation. Personally, I seldom use this because it's quite hard to memorize this equation. And then our observation is that lately on board exams, you are not asked to solve for the brake horsepower. You are just asked to solve for the horsepower of the compressor. So, pero if it so happened that you are asked for the brake horsepower, there are equations on the handbook that will let you solve the head, no, the head of your compressor. Just substitute everything right here. This is for non-ideal gas, ano? Kaya meron siyang compression factor. And if you want to solve the horsepower, you just follow this equation from the handbook. So this is from chapter 8, 10-74. Pero ganun din, ano, it's very hard to put this in memory, no? So generally, what our experience is, we're using the Cp delta T equation. And tapos we use the power is equals to m dot times delta H or WS divided by the efficiency. Pero in my previous experiences, this generally gives the same answer as that equation. The one on the handbook and the one based on thermodynamics gives the same answer. Pero the advantage of the delta H is equals to Cp delta T equation is you can commit it to memory. Pwede siyang maging stock knowledge. So let's try example 8.3 from McCabe. So we have a 3-stage reciprocating compressor. This is to compress 180 standard cubic feet per minute of methane from 14 psi to 900 psi. So from 180 standard cubic feet per minute, you can get the m dot. No, when you say when it's stated that it's standard cubic feet, it means that it is at 0 degrees Celsius and 1 atmosphere. And another thing, you can use the 359, no, the 359 cubic foot per pound mole. You can use this constant, to convert this to pound mole, and then if you have the molar mass, you can easily convert this to mass flow rate, So if you're going to use the SI unit 306 cubic meter, standard cubic meter per hour, halimbawa, you can use the 22.4 cubic meter per kilogram mole. So you need to remember this conversion factor. This is our at both of these are at STP, ano, standard temperature pressure. Okay? So these are the pressure. You just apply the adiabatic equation. P2 over P1 is equals to P1 over P2 is equals to T2 over T1. Quantity raised to K over K minus 1. Ganun lang naman yan. Then just get T2 and then just use Cp delta T. No? So the inlet temperature is 80 degrees Fahrenheit or 26.7. So this is T1. For the expected temperature range, the average properties of methane is Cp is equals to 9.3 BTU per pound mole per degrees Fahrenheit. Ito yung SI, this is the SI value. This is the gamma. Gamma is also Cp over Cb. Gamma is the same as K. This is the same as K. You know? Cp over Cb. So the first question is, what is the horsepower if the mechanical efficiency is 80%? So in solving letter A, the general equation for horsepower is P is equals to m dot times Ws divided by the efficiency. So just try to solve m dot from here, and then Ws is simply equal to delta H is simply equal to Cp delta T. Okay. And then letter B, what is the discharge temperature from the first stage? So just simply use the equation P2 over P1, this one. This is P2 over P1 is equals to T2 over T1 raised to K over K minus 1. Ano? If you happen to forget that equation, you can check it on chapter 10-44 from the handbook. Ano? So, hindi na lang muna natin isosolve yung letter C. Kasi mukhang pang ano na siya, ano? Pang heat and mass balance na siya. So, dito muna tayo. Let's concentrate on the calculation of the horsepower. Okay, so let me share a whiteboard para mas malinaw yung solution. Okay, probably let's start with the temperature. Let's try to find out the temperature. No? So our equation to find the temperature is simply P2 over P1 is equals to P2 over P1 raised to K over K minus 1. So let's try to solve K over K minus 1. K over K minus 1 is equals to 1.31. Ano? K is 1.31. 1.31 minus 1. So this is approximately 4.23. Then substitute the given right here. So P2 is 900 PSI. Okay. By the way, the pressure, the initial pressure is 14 PSI. And then the final pressure after the compressors is 900 PSI. Now, it's not allowed, no, that you will have a pressure ratio greater than 4 kasi mag-overheat yung mag-overheat yung compressor, and then upon overheating, it's common sense that the compressor will be damaged, kasi pag when the pressure ratio is high, the temperature ratio will be very high too, no? So it will result to damage in the compressor. So generally, we limit the compressor ratio into 4. So what we're going to do actually in the problem it is given that you will have three, you're going to use three compressors, no, in series. So balikan niyo lang yung problem. Ano, nakalimutan kong banggitin ng binabasa ko. You have three compressors in series, ano? So ang mangyayari if you have three compressors in series, you need if this is your final and initial pressure, you're going to take the cube root, no, to get the actual pressure ratio. Ganun yun, ano? Just take the cube root. Three compressors in series. So that's why this equation becomes like that, ano? So you have cube root of 900 divided by 14. And then T2 is 80. This is the initial temperature, no, plus 460. So I guess 80 is also given, ano? So to convert this to Rankine, you just add, this is degrees Fahrenheit, ano? 80 is degrees Fahrenheit. So just add 460 to convert this to Rankine. And then K over K minus 1 is 4.23. So with this, you can solve T2. So T2 is approximately 749 Rankine. And this is approximately the same as 290 degrees Fahrenheit. Okay, so to calculate WS of the compressor, this is equal to delta H, and this is equal to Cp delta T. So the Cp is given to be 9.3 BTU per pound mole, ano? Cp is 9.3 BTU per pound mole. Tapos delta T is 290 degrees Fahrenheit minus 80, no? 80 degrees Fahrenheit. This is BTU per pound mole per degrees Fahrenheit. So you will have BTU per pound mole as your WS. So something like 1,953, ano? BTU per pound mole. I hope you can follow. It's quite simple, ano? You just using the adiabatic equation, this one, you just get the temperature, okay? And then after finding the temperature, you can readily calculate WS by using Cp delta T. So you have 1953 BTU per pound. So after finding this, all you need to do is calculate the m dot, ano, the mass flow rate. So let's start with 180. So in finding m dot, let's start with 180 standard cubic feet per minute. So we simply divide this by 359, no, standard cubic feet per pound mole. So as you can see, this will be pound mole per minute, ano? And we don't need to convert this actually to mass flow rate, ano, kahit na n dot lang, kasi yung ating WS naman ay per pound mole, ano? So parang ang magiging equation dito is n dot times WS divided by efficiency, no? So as I've explained earlier, yun namang equation ng power, dimensional analysis lang yun, no? Ibig sabihin, magka-cancel out yung unit and then ang lalabas ay power. Pwedeng horsepower, pwedeng BTU per second, pwedeng kilowatts, joules per second, ganun lang naman yun. Okay, so this will cancel out and then I think mas maganda siya kung per second siya. Ano? So, multiply lang natin ito ng 1 minute per 60 seconds. So, ang lalabas ditong value is approximately 30.08. Ano? So, this is 30.08 pound mole per second. Okay, so just multiply this and then you will have BTU per second. Then divided by the efficiency. The efficiency is I think it's ano, it's pinalagay yung efficiency. I'm just going to check the efficiency, ano? Pero basically it's a product. It's going to check the efficiency. So 80% that's the efficiency, ano? Okay. So 80% efficiency. Okay. So to calculate the horsepower, this is simply this one, ano, WS. And actually, this is not M dot, this is N dot, ano, pwede rin naman yun. Tapos, divided by the efficiency. Just substitute everything. We have 1,953 BTU per pound mole. So let's multiply that by 30.08 pound mole per second. So this will cancel out. BTU per second na lang. Ano? Divided by the efficiency na 80%, 0.8. So in order to convert this to horsepower, I'm going to convert this first to pound force foot per second. So there are 778, no? 778 pound force foot per BTU. This will cancel out. So pound force foot per second, and then there are 550. I'm just going to divide this by 550. This is, sorry, 550. 550 pound force foot per second, no? For every BTU. Sorry, for every horsepower. So horsepower na to. Ano? Magka-cancel na kasi yan. Horsepower na yung lalabas. It's 195.2. So, yun nga lang, there are 3 compressors. So, kung ano man yung makuha nyo itong horsepower, multiply nyo ng 3. No? So, just put this in your calculator. 195.3 times 30.08 times 778 tapos divided by 550 so times 0.8. Okay? So I have, this is not 30.08. Ano, this is 3 over 359. This is divided by, ano, sorry. This is 3 over 359. So, this is 3 over 359. Ulit, sorry. So, it would be 195.3 times 3 times 778. Tapos divided by 550 times 0.8 times 359. So, you're supposed to get 1,953, no point 3 here. 1,953. So you're going to have 28.9 or 28.8. Ano? So the horsepower is around 28.8 horsepower or 28.9. Okay? So if you have, since you have three compressors, so the total horsepower is times 3. So that's approximately 87 horsepower. Ano? Pero pwede na rin naman yun. Kasi pag bibili naman kayo ng compressor, yung horsepower naman ng isa yung ini-specify niyo. So I hope you get the I hope you get these numbers, the correct numbers. I created this mistake. And please, pasensya na kayo. Medyo maliit talaga yung space. I'm trying to I'm trying to fit all this calculation in one whiteboard sheet. Pero madali lang naman, di ba? Just try to calculate the final temperature tapos multiply niyo lamang yung just calculate the WS after the final temperature, the WS. And then just try to calculate MDOT. Medyo nakakalito nga lang kasi medyo madilim, masikip yung space. Kaya I'm committing some errors. Pero ito rin yan. So, if you're going to multiply this value with this value, and then divide this by the efficiency and then perform some conversion. This conversion, you need to remember this 778 and this 550 pound force foot per second. You need to remember those conversion. 778 pound force foot per BTU and 550 pound force foot per second per horsepower. You need to remember those conversions to get 28.8 horsepower. The next question is, what is the final temperature? So we have earlier calculated that the final temperature is 290 degrees. This is the adiabatic temperature. Of course, meron tayong 80% lang na efficiency. So tapos actually dapat ang gagawin, babalikan niyo pa ulit, no? So babalikan niyo yung equation, ipapasok niyo dito yung actual delta H after the calculation of the horsepower, no? To find the actual final temperature. So babalikan nyo pa. Ano, ikasa-substitute dito. Kukunin nyo yung itong horsepower na to, ibabalik nyo pa dito. Ano? Pero yung sa ano kasi, yung sa libro, kay McCabe, hanggang dito lang. Hindi naman kasi kailangan talaga yung actual temperature. No? So, ito yung, this is the adiabatic ideal temperature. No, hanggang dito na lang tayo. Horsepower lang naman talaga yung importante. Later na siguro, pag nag-ano na lang tayo, pag nag-thermodynamics na lang tayo. Saka natin to gawing mas accurate. Ano? So in the meantime, kasi ito rin naman yung answer sa libro, yung 205 is okay. Tapos ito naman yung importante sa ngayon, na yung 28.8. Okay, so let's try to solve another problem. Ito lang yun, ano, before I leave this problem, yun, nakalagay kasi ito a three-stage reciprocating compressor. So that's why, pag three-stage, yung compression ratio is cube root of 900 over 14. Ganun lang yan. No? That's how you do it. If you have three compressors, you're going to get the cube root of the pressure drop to get the pressure ratio, the actual pressure ratio. So ang makakalculate nyo doon after calculating the temperature is the horsepower of its compressor. And then if you wanted to find the total, just multiply it by 3. Okay, so let's try problem 8.4, still from McCabe. No? Air entering at 70 degrees Fahrenheit and atmospheric pressure is to be compressed to 4,000 psig in a reciprocating compressor at the rate of 125 standard cubic feet per minute. If the compression ratio is 4, how many stages should be used? Okay, so how do we find this? So just equate the pag atmospheric, that would be 14 psia, you know? Tapos 14.7 psia. Tapos yung final pressure niya ay 4,000, 14.7 psia, you know? Just take the just get the on what route are you going to what will be the route to get a compression ratio of 4. Parang ganun lamang yan in order to find the number of stages. Parang 'di ba ito yung final pressure niya, no? Ito yung final pressure niya, 4,000 psig. So halimbawa, if this is PSIA, that would be 4,000 14.7 psia. You know? Tapos the initial pressure is 14.7. So we just find the root x so that this will be equal to 4. That's how you answer this question. How many stages should be used? How many compressor in series? Parang ganun yun, ano? Are you going to use? So if you're going to use your calculator, you're going to get something like, so that would be to the n, ano? Ito, 4,014.7. I hope you know how to process in your calculator. Tapos alpha equal. Tingnan natin kung medyo mabilis. Ano? Is equals to 4. You can use 1 over x, no? Parenthesis 4014.7 divided by 14.7 parenthesis tapos raised to x tapos yung ano yung x gawin yung 1 over x is equals to 4. Or pwede niyo rin gamitin yung root, no? Yung root yung ganun. And then just get the sheet solved. Medyo mahina na yung battery ng battery. Lumabas din naman, no? So it's approximately 4. So you will need 4 compressors for this compression. So pag later, pag malapit na kayong gumraduate, hindi, tandaan nyo, no? Hindi kayo pwedeng mag-compress from 1 atmosphere or from 14.7 to 4014 ng isa lamang compressor. Masisira yun, madadamage yun. Ano? So kailangan nyo ng 4 na compressor in series. So basically, this is the working equation. Ano? Basically, the working equation in order to find the number of compressor is P2 over P1. Okay, P2 over P1. Tapos, you just take the root or 1 over x is equals to 4. So, itong 4 na to ay rule of thumb. Ganun lang yun. Ano? In order to find the number of compressors in series. Okay. So, the next question is what is the theoretical shop work? That's WS. Ano? Or standard cubic foot for frictionless adiabatic compression. So WS lang yan. So WS is basically delta H and delta H is basically CP delta T. So ganun din lamang yun. No? And then the final question is what is the horsepower of its compressor if the efficiency of its stage is 85% for air. For air, K is equals to 1.4. So ganun din lamang yun. No? You need to find using this 125 standard cubic feet per minute. Ay kasi ito per cubic per foot na to, per standard foot na to, itong sagot sa pangalawang tanong. So i-multiply niyo na lang ito tapos yung minute gawin niyo lang seconds. Ano? Convert niyo na lang sa seconds. So, yun. Tapos yun, conversion na naman to horsepower. I think magiging pound force foot yan, ano? So pag naging pound force foot, gagamitin niyo yung 550. 778 tapos 550. 550 na lang pala. Gagamitin yung 550 na conversion factor. You really need to memorize those conversion factor. ang pansin ko, lalo na yung mga freshman, so mga sophomore na yun, they are using different conversion factor. Ngayon ko lang na-observe yun, ngayon lang nag-online. Ano? Probably most of you are doing your self-study and you have your own reference and you are not using the standard conversion factor na ginagamit sa Pilipinas sa local setting, ano? Tama naman 'yun, kaya lang most probably you will not arrive at the same answer. Kasi iba-iba yung significant figure nung ginagamit nating conversion factor. Yun lang yung nagiging problema, no? So, kung minsan pag naman nakita ko gano'n, nag-a-adjust naman ako sa sa exam. Naglalagay ako ng plus or minus. Yun nga lang, may disadvantage talaga. Paano pag hindi ko nakita, di dire-diretso. Parang pag majority, puro tama naman, puro 100% na lang. So unless you call my attention, i-correct ko yan. Ano? Yun yung problema pag hindi kayo gumagamit ng standard na conversion. Okay, so let's try to solve it. I'm going to share a whiteboard. So ito, okay na, we're going to use, tama na intindihan na to, di ba? We're going to use 4 for compressor in series, no? Kasi yung unang tanong. And then the second question is what is the theoretical shop work? So solve natin, no? Initial temperature is 70 degrees Fahrenheit. Initial pressure is 14.7 psi. Final pressure is 4,000 psig. So we're going to calculate the final temperature. And then the WS. Okay, so let me share a whiteboard. So we're on letter B, we're going to calculate the temperature using this equation. P2 over P1 is equals to T2 over T1 tapos raised to K over K minus 1. Let's try to solve K over K minus 1. May given naman tayong K or gamma, ano? So K for this problem is 1.0 1.4. It's 1.4, no? K for air is 1.4. You still remember the problem. So 1.4, 1.4 minus 1. This is supposed to give you something. Actually, hindi ko pala kinalculate. You know what I do is I place it in the equation. Ano? So this is equal to 1.4 over 0.4. And then itong P2 over P1, kasi sinabi ng problem, ang pressure ratio daw ay 4. So sinubstitute ko lang dito yung 4. P2 over P1. Ano? Tapos, I'm trying to calculate T2. T1 is 70 degrees Fahrenheit, if you still remember. So I just added 460. You can add 459.67. That's the more exact value. Ano? And then you raise this to 1.4 divided by 0.4. So T2 is equals to 787 Rankine. So you can convert this to degrees Fahrenheit. This is approximately 327 degrees Fahrenheit. So you can solve WS at this point. WS is simply equal to delta H, and this is equals to Cp delta T. Just substitute. For air, Cp is 7 hubs, no? Kasi diatomic to, di ba? 7 hubs. And then ang R ng sa English is, in terms of BT, is 1.987 BTU per pound mole per degrees Fahrenheit or Rankine. Ano? So this would be, final temperature is 327 degrees Fahrenheit minus 70 degrees Fahrenheit. So we're supposed to get WS equals to what I've done, kasi ang tinatanong is per cubic feet, ano? I already dinivide ko na ng 359. So hindi, pero gagawin ko sa inyo, dadandahanin ko na lang. We were going to calculate the standard WS. Okay, so times 1.987 times 327 minus 7. So actually masasabi ko madali lang naman, kaya lang ang magpapahirap ang talaga dito yung mga bagong constants, ano? Mga conversion factor, ang dami, no? So andun lamang yan. Pero pag na-eliminate nyo yun, relatively madali lang naman siya. So I have something like 1,787, ano? 1,787. This is, so pagka-cancel out ito, so BTU per pound. Kaya lang ang gusto nung problem is per cubic feet, ano? So basically gagamitin lang natin standard cubic feet. So gagamitin lang natin yung 359. So di-divide lang natin to ng 359. Remember, itong 359 is cubic feet per pound. So magka-cancel out na yun. Tapos yung nasa solutions manual kasi ay pound force foot per cubic feet. So para maging pound force foot per cubic feet, i-multiply lang natin ito ng 770. This is pound force foot, okay, per BTU. Okay. Cancel din. We have two constant here. Tapos ito 1.987 pangatlo, yung 460 doon pang-apat. So ito pa lang, ganitong kaikling solution, apat na yung memorize yung conversion factor. Ano? Yan yung nagpapahirap dyan. It's not really the mathematical equation. Pero yun, yung maraming constant na ini-introduce ko sa inyo. I think this is the standard na ginagamit sa Philippines. So please try to use this constant. Huwag kayong gumamit ng kung ano-anong constants. Conversions, no? Hindi kayo matututo dyan. Hindi nyo magiging stock knowledge nyo. Ito yung gamitin yung mga constants. Okay, makakalimutan nyo yan. So just 1,787 times 778 divided by 359. You have 3,873. Okay, and then there are I guess there are four. Ganun kasi there are four compressors. So you need to multiply this by 4. So pag times nyo ng 4, ayun, you're going to get the 15,000. Ano? So multiply kasi ng apat pala na compressor. Ang final answer kasi sa solution manual is 15,000. So you just multiply this by 4 for compressors. Kaya lalabas dito ng WS ay approximately 15,000, okay, pound force foot per cubic feet. Ito yung tinatanong sa WS. Now, okay. Susunod is you are asked to calculate the horsepower. So, tapos yung kinalculate naman niya sa horsepower ay per compressor. No? Yung head, 4. Ganun sa sa solutions manual. Pero syempre, ang tama dito is pag nagpa-exam naman ako, specify ko naman sa inyo kung anong head, kung per compressor or yung total. Okay, so, yun lang. So, yung susunod, yung horsepower, basically ang gagawin lang natin is, di ba may given naman na na cubic feet per minute. So, yung WS, i-multiply niyo lamang ng standard cubic feet per minute. This is standard cubic feet. Ano? This is standard cubic feet. So, i-multiply niyo lamang to ng what is given is 125 standard cubic feet per minute. So, just multiply this by 125 standard cubic feet per minute. Tapos 1 minute is 60 seconds. Yan, ganun lang. Yan, as you can see, this is pound force foot per second. And then you use the standard conversion. 550, 550 pound force foot. For every 550 pound force foot per second, this is equivalent to 1 horsepower. So magka-cancel out ito, yun, saka ito. So you will have the horsepower. Ito yung sa apat na compressor na Tapos, syempre, hindi naman siya 100% efficient. So, i-divide nyo pa rin ito ng efficiency. So, the efficiency is 85, no? So, i-divide nyo siya ng 0.85. So, just multiply this by 1 over 0.85. This is the efficiency. So, all in all, 15,000 times 125 divided by 60 times 550 times 0.85. You're supposed to get 67, 67 horsepower. So we have a horsepower is equal to 67 horsepower. Okay. Check 15,000 times 125 divided by 60 divided by 550 divided by 20. Malapit naman yun sa ano? Okay, so on the next video I'm going to discuss the meters, ano? So hanggang dito na lang muna itong video.